Hi everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 2099. Find subsequence of length k with largest sum. It's an easy from the LeetCode. So let's see what problem is basically saying. You are given an integer nums and integer k. You want to find a subsequence of nums of length k that has the largest sum. So return any such subsequence in integer array of length k. Okay. So yes, this is the definition of subsequence. We are not going to see again it. So this is the input. So if these are the numbers and this is the value of k, we have to pick two elements, okay, in such a way that when we add them, it will going to give the largest sum. So uh, obviously, the largest elements that are available, with the help of them only, we will going to create the largest sum, right? So whatever the top two elements that are available in our array, those going to be the answers, okay, because 3 and 3 are the maximum elements that we can retrieve from this array. So with the help of them only, we can actually get the largest sum. So in the output, we have to just print this one. In the second example, if you notice here, the k value is basically equals to 3. So again, -1, 3 and 4 are the largest elements compared with -2. So with the help of them, we can get the answer. Okay. So that is something what it is printed in the output. But if you notice here, the output are basically looking in a subsequence order. Okay. So -1 comes first. So it was added into the answer, -1 here, then 3 and 4. So order is also something we have to maintain. Again, here it is like 3 4 does gives us the largest sum. So that is something what it is printing, because k value is basically 2. So if we look into the constraint, so this nums dot length is basically less than 1000. So we can write the algorithm in n square as well. There is no issue with that. But during the interview might ask you to again improve the complexity. Okay, so yes, we should be prepared with all the different approaches. And yeah, that's all from this one. So let's what we will do is, let me try to connect it and I'll discuss different approaches and we'll write the solution. Okay. I hope the screen is not up. Wait. Yeah, I guess the screen is up now. So what the first basic idea what we can do is, we will start from this 0th index. We will run another loop from the 0th index. Okay, wherever the I basically pointing, I is basically 0. Second j is basically pointing to I, and it will go till n. This will also go till n, and we'll keep on checking which is the largest element from this current. Okay, so whichever the largest element that we got so far from going through this, 7 is the largest one. So 7 is something what we will pick. Okay, the moment we pick the 7, so we notice that this 7, basically whichever the seventh element is, we will mark it as I mean, we can maintain another index where we can mark them whether they are picked or not picked. So it is actually picked, so we will mark it as true. In the next sequence, we will again start here and go by going here, whichever the largest element that we got, that is something what we will pick. Okay, from the 0th index only, again we have to start. Okay, so that is something what we have to notice, because 4 is something what getting left out. So yes, again we can mark this 4 as true, because 7 is now picked, so we cannot consider it as a maximum one. So again 4 is the maximum. Second also we got, again we will start iterating, and the third is again the last measure, I mean biggest element that we got. So we will know these all the true values, whichever the index we are having, those index only we will pick. So answer is like 4 3 7. Okay, because top three elements is something what it is asking. So based on this particular whatever the another array that we have maintained, based on that we can write output. Okay, so this is like n square. In the n square, we will write down this code, and again storing this whatever the true or false flags, it is going to take big O of n. Okay, this way we can write down the code. Okay, this is the first approach. Now further can we improve it, right? So yes, obviously when we sort the data, we are clear that whichever the top elements, highest elements, okay, either we sort it in ascending or descending order. Let us suppose 7 4 3 2 minus 2, this way we have sorted the data. Okay, now top three elements are basically going to give us the sum, because k is basically 3 and we are looking for the top three elements only. So this is the first answer that we can consider, but we have to write the answer in this fashion, right? 4 3 7, and our answer basically looking like 4 7 3. In any of the way, whenever we sort the data, the order may be mismatched. Okay, because these values are not getting sorted based on their index. These values are getting sorted based on their whatever the value that they possess. Okay, so how to make sure that this order is basically maintained and we can write the output in this fashion, right? Because now we got these values, but they are not in a sequential order. Okay, what the order, how the numbers of array is basically given, it is not in this currently in that order. So what we can do is, basically we can maintain their index while sorting. So seventh index along with this 7, what we will do is its index is also we will store, along with the 4 its index also we will store, along with 3 its index we will store. So 3's index is basically 3. Okay, and these are the top elements. Here again we can maintain their index, so it is 2, here it is again 1. Okay, this way we will sort the data. Okay, so now we have their index. Again, this particular array, whatever we have, top k elements that we have, based on these values, whatever we have, we can create another array, and that whatever the array that we have created, these top elements only we will pick and put it into that array. Okay, and these whatever the elements that we have, again we will sort them based on the second value. Okay, so then once we sort it, so data is like 4 0, okay, 3 3 and 7 4. We will sort them in ascending order. So at the top, 0th element is there, third element is there, and next fourth element is there, because this is the answer that we will be going to have. That is clarity. So again, we only sort them based on their index values. We will pick them, we will put it into the another array, and we can sort them easily. Okay, this is like with the help of arrays we can sort it. So with this array, it is like n log n is the complexity, and storing the data, it is like here it is n, here it is k, so n plus k is the storage that we are required. Okay, and again it is storing 2 index values, so it doesn't matter, like, okay, so that's how we are storing the data. Okay, n plus 2k is the storage that we will be required. Okay, it is basically n plus k only ultimately. So yes, this way we are basically sorting and getting the answer. But with the help of min heap, this whatever the n log n complexity that we are having, it will get reduced to n log k. How? So in the min heap, what we will do? We again sort the data. Okay, let me just clean up all these things. This was the second approach. With the help of min heap, we will see like how we can do it with the help of priority queue. So what we will do? So this whatever the data that we are sorting, let us suppose 4 is something what we got. So this is the heap we have. 4 is currently in the heap. The second is -2 and 1, so it will be at the top. Then it is like 2 and 2, so it will be somewhere here. It is like 3 3, it will be somewhere here. Okay, and then it is 4 7, so it will be somewhere right over here. Okay, so here the k value is basically 3. Now we sorted the data, and we can keep on popping them until and unless the size, heap size, is basically equals to 3. Okay, this way we can store the data, but while storing the data only, we will make sure that the whatever the heap size is there, it is not going beyond this k. Okay, so during the sorting, okay, the first element was like 0 4. Okay, 4 and 0 is something what we added. We check that its size is, if it is greater than this k value. No, it is not, right? Currently its size is only 1. Next is 1 minus 2, so it will be available right at the top, -2 1. Next is 2 and 2, so 2 and 2 is also got added. So with these three elements we are not having any problem currently. The moment we add 3 and 3, okay, we now notice that size is basically 4 and the k value is basically 3. So whichever the top element is there, we simply pop it up. Okay, now this is not available in our heap, so size is basically again maintained 3. Next is again 4 and 7. So 7 4 is basically 7 added right over here, 4 is basically right over here. Okay, it was 7 4. Okay, so again the size is basically 4 and the k value is 3. So again we will keep on popping the whatever the top element that is there. So this is how the data basically getting stored. So this whatever this processing it does basically takes n log k. Okay, now the moment we sorted the data is again in the sorted order, and top k elements only we will be having here. So again, whatever the element that we have, we will use another heap where we can sort the data based on their index values. Okay, so yes, obviously we have to use two different operations to resort this data. So again, when we sort the data, it is like 4 0 3 3 7 4. Okay, based on these values we sorted them. Okay, this is like we can use another heap and we can put this data in that one. Now this data is sorted, so we can create another answer array, and we pull out this data and we keep on filling this value. So 4 3 7 is the answer that we will get. Okay, this way we can solve it. Okay, we have numerous approaches with which we can solve this particular one. So let me just write down this min heap one, and you can write other approaches. Okay, so let's create a priority first. Okay, it is not getting reflected, and here it will store, let's store int which is having size of 2. and inside we have to give how we are going to sort the data. So at the 0th index, let's store the arrays value. So based on the arrays value, we are sorting it. So p of 0 minus p of 0. Okay. We have sorted it. So let's name it as first. And what we will do is inside this one, we will simply put the data. So we'll go through this nums array int I equals 0, I less than nums dot length. Okay, I plus plus. Here, what we will do is we simply start putting it into the pq dot add offer anything new int this nums of I and I. Okay, and we will check that if pq1 dot size actually, the moment if it is going beyond sk, we will simply pull whatever the top element that is available from the pq. Okay, I already shown you like how we are doing it. Now this is like it will just hold top k elements into the pq. Again, we have to create another priority queue so that we can sort the data, whatever this priority queue, previous priority queue it is holding. We'll sort it based on their index. Okay, so here I'll keep 1, so that at 0th index we are actually having nums of I. At first index we are having index value itself. So based on the index, I'm sorting it and adding it data inside it. So again, we will run the. I mean, we can use priority queue to get this data while not pq dot is empty. We'll keep on pulling the data and add it into the pq. So pq2 dot add this pq1 dot pull. Okay, we are pulling it and adding it into this one. Now this pq2 will take care so that the data will be sorted based on the a of 1 and a of 1. I mean the based on the index it is sorting the data. Okay, now it is done. Now we will simply create the answer. Int answer equals new int k. Okay, in this one, now whatever the pq2 holds the data, it is actually in a sequential order. Okay, that is something what we have to write it into the output. Okay, what we will do, simply again we will pop the data from the pq2 dot is empty. Let's get the current values. Val equals pq2 dot full, and inside this answer of I, let us create here counter int idx equals 0. Here it should be idx plus plus. Okay, we are just simply getting these values of 0 and adding it into the answer. Okay, because this pq2 basically holding the index as well as the number. At 0th index it is holding the numbers. Okay, that's all. We can return the answer now, and if we try to run this one, it should work fine. Let's see if we have any errors. Okay, pq should be 1, and do we have any other errors? No. Run. Okay, again pq1. How many times did I write this? I have, okay, didn't got modified. It is working fine. Let's submit this, and you can try other approaches as well with the help of array itself. So you can try to sort the data and try to get the answer. Okay, so it is beating 91% and it is good. I think it is acceptable as well, because apart from this we cannot further reduce the complexity to make sure the size is basically less than this log n log k. Okay, whatever the complexity that we are getting. So yes, this is how we can solve this particular one. And yes, if you enjoyed this one, please make sure to subscribe to this channel as well. Thank you for watching this video. Bye bye.